Hi everyone, my name is Ryan Chase. I'm leading the USC Aerial Robotics team this semester, and I'm making this video for those of you who couldn't make the information session that happened last night. A few of you have reached out to me personally, and I know that there was just a lot of people who couldn't make the meeting. If you couldn't make it, no worries. I just wanted to quickly go over the material. And so that way you know what you're getting into if you still would like to apply, and we want you to apply. Okay? So without further ado, we are the USC Aerial Robotics team. We build drones and we compete in international competition. We are in our 8th active year, and our emphasis right now is on software. Let's see. Currently, every year we go to, or we attempt to go to the International Aerial Robotics competition, and so the way that works is there is a mission that they have specified for to challenge the participants, and this year's mission is there is a big arena inside of a gym, and you've got a bunch of Roombas that are on the ground. And your goal is to move them from one side of the room to the other across the finish line. Moving a Roomba across the finish line will get you a point. You score points that way. And the hard part about this challenge is that it has to be all done autonomously. So you can't use radio, and you have to program everything to make it autonomous. So it's an interesting problem. In 2015, the winner went to a team that only got one Roomba across the finish line. And every year, when they deem that they haven't successfully solved the mission, it just keeps going, and the prize money just continues to pool up. So this is the 4th year of the International Aerial Robotics competition doing this particular mission, and so we are continuing on. And pursuing this one. So this one is a video kind of going over, it's a little dramatic, but it goes over the competition and the mission. You should watch it if you haven't already, just to give you an overview, and I'll sort of make references to it later in case you were wondering exactly how things worked. So now what I'm going to do is go over the 2 teams that we have on our software team, and I'll sort of detail what you can expect to work on if you are considering both. So on our low-level team, you'll be working directly with our flight controller and the sensors that get integrated into it. So that means we've got the accelerometer, gyroscope, the downward-facing camera, and using calculations like optical flow. So these are all for calculating your position, and eventually it's going to be going into maintaining stable flight and having smooth transitions from moving from point A to point B. And this is really, really important for setting everything up for the high-level team. And so some of these sensors, for example, the accelerometer and the gyroscope, they work together to help calculate your orientation, and then the cameras work together with the camera works together with the flight controller for optical flow, and we'll go over some of these more technical terms later, but essentially are able to calculate your position based on differences in many images taken over time. And then let's see, another major task is just general stable flight. We want to be able to do takeoff and landing, and eventually move into more aggressive maneuvers. You'll see in the video that if you're flying around looking for a drone, looking for a Roomba, you have to keep out of the way of these poles that are moving, poles that are attached to other Roombas. So if you're unaware of moving obstacles, your drone could get hit out of the air by one of these giant poles that'll just come moving towards you. So there's a lot of obstacles, and the low-level team is responsible for making sure that the high-level team has the capabilities and functionalities to execute those routines. So moving on, so high-level We've got target detection and identification, so that's just essentially finding the Roomba. And as you can see, some of these Roombas have special platings on top of them to help the drone realize what is a target and what isn't a target. You got obstacle avoidance. As you can see in that picture, there's these poles that are on top of some of those Roombas. And so these poles will be moving towards you or around you, and you want to make sure that you don't bump into it and compromise the mission. And the entire arena is mapped out, and you're going to want to keep track of essentially where everything is at a given point in time. And so that's an interesting challenge as well. If you have further questions about specifics of how these things work, my email is going to be posted at the end of this. Our high-level lead, Matt, his email is going to be posted. So you can reach out to us with further questions, or you can ask us in person too, if you like. So, and of course, you've got path planning, which is essentially, moving from point A to point B is fine until point B is moving around, and it becomes a much more interesting challenge. And figuring out what state each Roomba is in. The Roombas, the way that you interact with them, essentially, normal Roombas will just move in a straight line until it hits an obstacle. But for this competition, they have their own Arduino file that sort of programs them to move in a straight line, and then every so often sort of change their direction by like 20 degrees or so. So it makes it difficult because even though you may have pointed them in the right direction in the first place, they might change their mind later. The way that you interact with them, and this is important, I left this out a little bit earlier, but the way you interact with them is you can either block their path completely. So if you land your drone right in front of your Roomba, the Roomba will be like, oh, there's something in front of me, and it'll turn around completely. So that's good if you got a Roomba facing the wrong direction, moving in the wrong direction completely. And otherwise, you can lightly land on the Roomba and just touch the top of it, and that will slightly adjust the rotation of the Roomba. So that's if you want to make it more fine-tuned, just sort of move it from one angle slightly to the left or so. Left or right. And then obviously there are concepts for like goal prioritization. We want to make sure that we get the most points possible, so we have to calculate which Roombas are worth going for and which ones are maybe, given the time constraint, not the ones we should be going after. And obviously there's obstacle avoidance too. I forgot to mention, let's see, for the low-level team, you're going to be working with the Pixhawk libraries, and those are all C++. High-level team, it's also C++, but you've also got a few of these frameworks here. There's ROS, and that's essentially working, it's sort of a way for these sensors to interact with each other and to make these calculations. So if you've got a sensor that's calculating optical flow, you want a way to get that information to another application running on your drone that is going to be saying, okay, oh, this is where we are. Okay, so I have to calculate where in space I should move next. So ROS is how robot operating system is how we're sort of interconnecting sensors with the programs that are actually doing these high-level calculations. OpenCV is a computer vision library. Eigen is a linear algebra library. You'll be working with these and plenty more technologies moving forward. These are just some of the important ones. Here's some pretty pictures. We have a drone right now, and it doesn't look quite as nice as this, but we are working this whole year on making sure we have a competition-ready drone. So you'll see that if you make it to our first session. Let's see. And then our ultimate mission is to essentially do the best we can on this mission, and hopefully, when what some people might not know is that last year, this past August, we did not make it to the International Aerial Robotics Competition. The year before that, we didn't make it to the International Aerial Robotics Competition. And the year previous to that, we did. But it's interesting to note because this competition schedule can be tricky. And one of our really, really big main goals that we are accomplishing this year is making sure that we actually go and we actually have a competition-ready quad. There's always been a few different reasons why we haven't been able to go, but we're pretty confident this year is going to be a much stronger year for us in terms of getting everyone ready. And if you do end up joining the team and you are interested in going, so the United States competition, I think, is in Georgia. If you are a contributing member and you attend all the meetings as best you can, you're probably very likely to be joining us going to the competition. Last thoughts before I end this session. For those who went to the info session, you realized that there are only 5 of us on the team right now due to some leadership issues and just figuring out how we wanted to organize the team. We had some trouble maintaining our numbers in previous years, and in the result, our core members, there's very few of us. So I think that guarantees a few things for those of you who are looking to join. I think it guarantees that there will be plenty of work to do, and we don't want to scare anyone away, but this is going to be a good amount of work, and you can foresee yourself being in the lab with us a lot. We have lab times from 7 p.m. to 9 p.m. on Tuesdays and Thursdays every week. But meeting times are at the discretion of the team leads. Recently, one thing that was discussed at the info session was some of them might have been in favor of moving the meeting time back an hour, so it may be meeting from 8 to 10. I know that I'll be here, or I will be meeting with the team as much as I can, as much as my schedule allows. So we will make official announcements on how often we're meeting, but it can be flexible. So if you find that Tuesday, Thursday doesn't really work for you, we are going to be breaking down into sub-teams. And of course, those sub-teams can meet whenever is more convenient. The second thing that I want to guarantee you for working with such a small team is that you're going to make a serious impact on this team. There's a lot of work to be done, and you can pretty much guarantee that moving from right now, if you've seen our quad, it looks kind of dinky, and the most we've been able to do with it is get the motors running, and we know that it's able to fly. But if you stick with us and you put in the time, and you really have a desire to see this go from beginning to end, there's some amazing things going to be happening, and it's going to be we're going to accomplish a lot in the span of a year, which isn't a whole lot of time. But lastly, I'm this one is not a guarantee, but I'm very, very certain of it. The skills that you learn while working on this team will get you an internship. There's no joke about it. We do some serious work. This is some very relevant industry level work that we're doing. So if you're interested in aerospace, if you're interested in AI or computer vision, or just in robotics in general, this is the place to be. You will learn some real skills, and on top of that, you'll be making some good friendships with us on the team. I mean, if you are interested in one of the places that we've worked at before and you'd like to recommend, I'm sure that we will be super happy to accommodate because we'll be going through a lot this semester, or this year. Okay, one last note. We don't want to just make it all work and no play. We're going to be spending this much time together. We're essentially a big family, so a couple things we're planning on doing is we want to do fun things with the drones. I mean, we're a drone team, so we should use the drones. We're going to be racing them and learning how to fly them. We know that places like JPL, they have open labs. I have a buddy over at Northrop who's trying to get us into their telescope viewing. They're building a telescope right now. There's more casual stuff. Maybe every Friday we're going to get together and just have some pizza, play some games, and do some work. And there's also chances for community involvement if you're interested in that. Okay, last step. In addition to this, you'll get a link with the application. It's a Google form. It's a few pages long with just basic information and then solving a technical problem, we're not actually looking for like perfect code. We want to be very far removed from that. I'll just say that what I'm looking for in the application is that you exhibit the ability to look at a problem and recognize the steps that might go into solving a problem. I don't need you to implement everything. I don't need you to like have this fully tested and automated. Just be able to solve the problem. Or come up with a solution. I'm not looking for the best one, just a solution will do, and that'll go a long way. And then you'll specify which team you want to work on. So there's the high level and low level, there's different tasks within those, and you'll get to see what exactly you might be working on. Our application, is that date correct? The date might not be correct on that, I'll double check. Essentially, we want it to be due a week from yesterday, which was the 6th. Yesterday was the 6th. So, yeah, I think it's actually not going to be due on the 9th. It's going to be due on the 13th. And we will let you know by the 15th of September. Okay. That's it. Thanks so much for tuning in. Thank you for attending if you could make it. Otherwise, no worries. I realize that this came out very, very late, and so if you had a scheduling conflict, that's fine. Please feel free to reach out to me. Matt Buckley's our high-level lead, and Vadim, he's our low-level lead. You can reach out to any of us for questions about what you'll be working on, the application, and yeah, so thanks again. We really hope to hear from you soon. Thanks so much, guys.